Welcome to an introduction to the idea of modeling in math and society. So math and society, we have several types of functions that we try to model, and one of those is linear. Those are the most basic. So linear functions are where we have a constant increase or a constant decrease, and so the graph of something like that would form a line. So for example, let's say you rent a car for a certain amount of dollars. It starts out here as a kind of a starting point, and then it increases at a constant rate. So that might be the cost per mile or something. And so that's a positive. We say that's got a positive slope there. And then you might have a linear function that has a negative slope, and that might be somewhere like, okay, you're a certain distance from a location, and you're getting closer and closer to that location at a constant rate. So let's say you start out at some distance here, and it decreases over time. So, you're driving at a constant speed, and so that's a decreasing function, and it would have negative slope. Now, another type of function that we deal with in math and society is an exponential function. Exponential functions are common in population growth and let's say also with investments. So exponential, and so with like investment money, you start out with a certain amount, and then it earns interest, and the interest earns interest, and so we get this increasing. It's not a constant rate of increase. It's the rate of increase increases. So it starts out growing, and then it grows faster and faster as the interest earns interest itself. So that would be where we say the growth factor, or the multiplier, or the b is often what we use there, is greater than 1. So you're multiplying by a number bigger than 1 over and over again. Now you do also have exponential decay. So like, for example, if you put a hot cup of coffee get a hot cup of coffee out of the microwave or something, and it starts out at a certain temperature up here, and then that temperature decreases over time. So it goes like this as it cools off. And that is where the b value, what you multiply by, is a fraction, something between 0 and 1, some proper fraction between 0 and 1. And lastly, functions that we talk about are logistic. And that is something that typically starts off looking exponential, but then it kind of changes. So it might start off looking kind of exponential. Looks like there's a common ratio, but the ratio, it gets slighter and slighter and slighter until it kind of reaches this point of inflection, and then it turns over. And the reason this happens when there's exponential growth, like in a populations, if you look over here, populations, notice this arrow that keeps going up. Populations really typically do not go to infinity, as that graph seems to imply. Usually there's some limitation, like fish in a pond, or animals in a certain area. There's only so many animals it can reach, so there's kind of this cap, this limit on the top, how far it can go, and so it gets closer and closer to that limit. It slows down the growth. Now there are a couple other possibilities. One is it might overshoot that. Let's say there's this carrying capacity is what we call that. If it starts to go up and then goes up pretty steeply, let's see, I gotta change this here. Goes up pretty steeply, it could overshoot and then correct. So sometimes logistic functions, if we look at it, they can do something like that as well. So just so you know, there's a few different possibilities for modeling data. Is this video helpful?